Hello, this is O. Morgan from omorganlabs.com. We're going to talk about shear and moment diagrams today. First off, we have to talk a little bit about what is shear. Okay? Well, shear is when you consider a small element inside of your object. For our purposes, we'll assume this little square piece. And if we focus in on that little square piece, we have a force going down on one side, force going up on the right. And if you put the two forces together, you'll have something like this. Okay? So imagine a box and you have forces adjacent to the sides. What will happen is the forces will tend to want to rotate the little element, right? But this is static, so it's not going to rotate. It's just going to apply a pressure, a stress that will tend to rotate it or want to rotate it. And so we define this rotation, the counterclockwise rotation, as a negative shear. And we use the letter V to indicate shear. So negative shear is counterclockwise, CCW. And if we just flip it, if the forces were going in the other direction, we would have a positive shear. So if the shear forces want to rotate in a clockwise, the little element in a clockwise direction, that's positive shear. Okay, so we have our definitions for positive shear and negative shear. Okay, now let's talk about moments. Okay, we'll go back to our original problem. We label each force with a letter A, B, C, and D so we can break down the different sections. Okay, now let's concentrate on A, B, C. Okay, section A, B, C. If you look at that, you'll see that A, B, and C, or not A, B, and C, B, C, and D. If you look at B, C, and D and break that out, you'll see that you have forces going up and down, wanting to bend it concave up. If you remember that terminology from your calculus class, concave up is when you have a smiley face. That's the simplest way I can put it. So you have this, a smiley face. Concave up means positive moment. Simple as that. Some textbooks say if the forces bend it so that it can hold water. So if you can imagine water here, it could hold water if you were so inclined to fill it with water. Anyway, positive moment. So to look at the negative moment, now we'll look at section ABC. Okay? Now we'll look at section ABC. So we have forces going down and up, making a frowny face or concave down. So concave down means that you have negative moment, concave down. So to put everything together between A and B, you think about the little piece, force going up and down in a counterclockwise fashion is a negative shear. Between B and C, the elements, they want to make a clockwise rotation. So that's positive shear. And then this last section, CD, you think of the element and the forces want to rotate it in the counterclockwise direction. So that's a negative shear. So now let's think about the moments. Remember, A, B, and C, the forces are wanting to bend the beam concave down, frown. So that's negative moment. B, C, D, the forces want to bend it concave up, smile, positive. So that's a positive moment. But there's one little caveat here, one little trick. There's an inflection point here where you go from negative to positive. In order to figure that out, you're going to have to use the actual numbers, right? I don't have any numbers here. I'm just trying to illustrate the concepts. So if you have this is, you're like 90% of the way there. Well, not really, probably 50%, because you have to use algebra and everything to figure out specifics. Anyway, I hope you get the basics of shear and moment. This is omorganlabs, and subscribe.